So just like y equals x squared plus 1 creates the shape of a parabola using rectangular coordinates, there are, instead of an equation using rectangular coordinates x and y, there are polar equations which use the polar coordinates r and theta. So for instance, this one looks a little wacky. R equals theta over 2 plus 0.2 sine of 4 theta plus 1. It's a polar equation. I don't expect you to know what this looks like. I would not have known what this looks like without using a tool like this. So you're seeing over on the left a theta axis and an r axis, and you'll see that r mostly increases as theta increases, but the r does also dip down a little, and that's what creates this shape over here. Again, I'm not expecting you to recreate this. I don't have a theory to tell you about. I would not be able to create this, at least without the help of a scientific calculator at minimum, where I could plot some points or something like that and then connect the dots. That's all I have for you for this. Don't worry, most of the things we're going to look at to plot for polar equations don't look nearly as complicated. We're going to look at much nicer things like just r is equal to 8 times secant of theta, for example. So first of all, let's describe the graph of r equals 8. So we're getting all of the points where the polar coordinate 8, the polar coordinate r, could be 8, would apply. And that would just be a circle of radius 8 centered at the origin. How about the graph of theta is equal to pi over 4? Now, the natural instinct is to say, okay, pi over 4, that's 45 degrees. So if you start at the origin and you travel to the northeast along that 45-degree angle, get all the points that you get traveling directly to the northeast. And you do get all those points. But you get more than just the points in that ray, and that simply has to do with the fact that when r is negative, you travel in the opposite direction. So the opposite direction of this pi over 4, it's 5 pi over 4. So let's say theta was 5 pi over 4, but r was negative. You end up getting this entire line. So this tangent of pi over 4 is equal to 1. You get a slope 1 line that goes through the origin. Now let's look at the equation introduced a moment earlier. R is equal to 8 times secant of theta. Now, can we convert this into an equation in x and y? We sure can. So first of all, let's rewrite secant of theta as 1 over cosine of theta. So we leave the r on the left side alone, leave the 8 on the right side alone. We've just rewritten secant of theta. Multiply both sides by cosine of theta, and you have r times cosine of theta is equal to 8. And so you have x is equal to 8. Okay, so you just really get a vertical line, x equals 8. What about r is equal to 8 cosine of theta? Can we convert this into an equation in x and y? Yes, although not exactly the same technique we saw is going to work. We're going to have to try something a little more creative. And here, the thing that actually works is multiplying both sides by r. So then we'll have r squared is equal to 8r cosine of theta. Now take a look. That 8, I was going to focus here on the copy the 8, and then r cosine theta is x. Going back to the conversion formulas we saw, r squared is 8 squared plus y squared. Now if you think of what this really is, so far we're really seeing a circle, though it's not currently in its standard form, so let's subtract 8x on both sides, complete the square, and this ends up being a circle of radius 4 because of the 16, centered at 4, 0. That's what this really is.